All right, so the next thing we're going to do in the trig unit is we're going to look at the double angle formulas and the half angle formulas. So here are the double angle formulas, and you'll notice that with sine and tan you only have one option, and with cos you have three options, and honestly you can just pick one and stick with it, or if you get bored you can switch it up. You'll get the same answer with all three of those cos options. So first we're going to go ahead and we're going to find, so here's our example, we're going to find sine 600 degrees, cos 600 degrees, and tan 600 degrees. Using the double angle formulas. Okay, so first with sine 600, I'm going to rewrite this as sine of 2 times theta, so this would be 2 times 300 to be able to get to 600. And then I'm going to go ahead and use the formula that we just looked at. So it's 2 times sine theta times cos theta. So this is going to be 2 times sine of 300 times cos of 300. And if you look at your unit circle, you will notice that sine of 300 is negative root 3 over 2, and cos of 300 is 1 over 2. So if I go ahead and multiply these, I'm just going to say multiply by 2 and divide by 2, those are going to go ahead and cancel. And then I can just multiply straight across, so I have negative root 3 times 1, which is negative root 3. And then I've got 2 on the bottom. So sine 600 is negative root 3 over 2. Now, this is probably going to be frustrating to you because it's not practical. Like if you wanted to do this problem, you could just say, all right, 600 minus 360 is 240. Well, that's on the unit circle, so why wouldn't I just look there? And the answer is, you probably would look there and then you just have the answer. But we do need to practice using these formulas, and so that's how you're going to practice it. So if you wanted to check your answer, you could just go ahead and we're going to say 600 minus 360 is 240 on the unit circle. And if you look to see what sine of 240 is, it is negative root 3 over 2, so you know you got the answer right. You could also plug in sine 600 in your calculator and verify that that decimal matches up the same decimal for negative root 3 over 2. So you have a few ways to check your work here. Okay, so next we're going to go ahead and do cos of 600. And so with cos of 600, we have 3 options to use for our formulas. I'm going to go ahead and just use the first one, cos squared minus sine squared. And so we're going to say, again, this is going to become cos of 2 times 300. And so we're going to do cos squared of 300 minus sine squared of 300. So again, cos of 300 was 1/2, so I'm taking that value and squaring it. And then sine of 300 was negative root 3 over 2, so I'm going to take that and square it. And when I square 1/2, I have 1/2 times 1/2, and that's going to give me 1/4. And then when I square negative root 3, that just becomes 3, because negative root 3 times negative root 3 would become a positive. And then 2 times 2 is 4. So I've got 1/4 minus 3/4, that gives me negative 2/4. And then I can go ahead and simplify that. Both of those are divisible by 2. So that gives me negative 1/2 is my final answer. And again, you could say, all right, let's look at the unit circle. It's 240. The x value there is negative 1/2. Or you could plug it into your calculator to double check. And last, we'll go ahead and do tan of 600. So again, this is going to be tan 2 times 300. And the tan formula is just, it's a little bit more complicated because it is a fraction. So we're going to do 2 times tan of 300 over 1 minus tan squared of 300. So if you look at your unit circle, tan of 300 is negative root 3. So on the top, we're going to have 2 times negative root 3. On the bottom, we're going to have 1 minus negative root 3 squared. So if I do this problem, the top is going to become negative 2 square roots of 3. The bottom is going to be 1 minus negative square root 3 squared is 3. So we have negative 2 square root 3 over negative 2. The negative 2's cancel, and our final answer is just square root 3. And again, if you looked at 240 on your unit circle and you did y divided by x, you would get root 3. Or you could plug in tan 300 on your calculator and verify that those decimals are the same. All right, next we're going to go ahead and look at the half angle identity. So you've got one option for sine and one option for cosine, but tangent, you'll notice, has 3 options. And what we're going to do is we're actually going to focus on the first 2. The last one we're probably not going to use just because it's a lot more difficult to simplify, and it's unnecessary because you have the first 2. So we'll go ahead and focus on those. So for our example, we're going to go ahead and we're going to find sine of 67.5 degrees and cos of 67.5 degrees and tan of 67.5 degrees using the half angle identities. And the nice thing about this formula is that these answers are not on the unit circle, so it actually feels like they have a purpose to be trying them. So one thing to notice in those equations is that a lot of those equations, not all of them, but a lot of them have that plus minus there in the front. That doesn't mean that you get 2 answers. It means that you have to consider which quadrant you're looking at. So that might be something to add to your notes off to the side if you guys recall. The first quadrant, all of them are positive. And then we have all students talk constantly. So second quadrant sine is positive, third quadrant tan is positive, fourth quadrant cos is positive. So we're going to have to consider where the angle is that we are looking at for that particular problem. And that will help us determine if we should do the positive version or the negative version. So if we're looking at sine 67.5 and cos 67.5 and tan 67.5, the nice thing about this is that those angles, that's the first quadrant. So these answers, we're looking at the positive version. But you'll always want to take that into consideration when you do the problem. All right, so to start with, we're going to go ahead and do sine 67.5. So I'm going to rewrite this as some angle divided by 2. So the angle that you would have had to divide by 2 to get to that is 135 divided by 2. So to get that started, I know I'm doing the positive version of the square root. So I'm going to go ahead and write out the formula. I have 1 minus, cos 135. And all of that's being divided by 2. And so in this problem, I know I'm not going to use the minus sign because I'm in the first quadrant. And then I can go ahead and simplify this a little bit. So I have 1 minus, and then cos of 135 is negative root 2 over 2. We got 2 on the bottom. Now I know on the top I've got a fraction and something that's not a fraction, so I'm going to want to be able to get a common denominator and then push those 2 fractions together. So now on the top what I have is 2 plus the square root of 2, and that's because that minus minus right there made a plus. All of that is divided by that common denominator of 2. And then on the bottom of this, I have a 2 over 1. All right, so I'm going to go ahead and take this fraction and flip it up so that it's multiplying by 1 over 2. And so what I have now is 2 plus square root 2 over 4. And now I can split it so that basically I have a square root on the top and a square root on the bottom, like that. And so the square root on the top is just going to stay like that. It's just going to be 2 plus the square root of 2. But on the bottom, the square root of 4 is just plain old 2. And we always want to do that because we don't want to have a square root on the bottom of a fraction, so it's important that our final answer looks like that. Now in this problem, we're actually going to want to go back to check our answer. And so I went ahead and plugged it on my calculator just to double check. So you can see that I plugged in the square root of 2 plus root 2 over 2, and that I got the same decimals when I plugged in sine of 67.5. So that just helps me to verify that my final answer does match up. The only downfall would be if you didn't simplify it completely or something and you left like this is your final answer, then on the calculator it would still show up as being right because it technically is the same decimal, even though it hasn't been simplified all the way. So that's one thing to watch out for. Your calculator won't necessarily be able to tell you that part of it. Okay, so let's go ahead and do cos of 67.5. And I know that process seemed kind of complicated, but the nice thing is these problems are very repetitive, and so you'll notice you're doing the same thing over and over again, and so you'll get kind of used to it. So here we're going to have plus minus, and then it's going to be 1 plus cos 135 over 2. And so again, we're not using the minus version. We're using the plus version because this is a first quadrant angle. So I've got 1 plus negative root 2 over 2. And then again, we're going to, before that, divide by 2, okay. And then again, we want this to get a common denominator so we can put those two things together. And so when I do that, on the top of the fraction, I have 2 minus root 2 over 2. And then on the bottom, I have 2 over 1. And just like before, we're going to take that 2 over 1, we're going to flip it up and multiply by 1 over 2. So you'll notice this problem is working out very similarly to the one that we just did. So we've got 2 minus root 2 over 4. And then again, just like before, we're going to split it. So we're going to make the square root go on the top and the bottom instead of just being over the whole fraction. So our final answer here is going to be 2 minus root 2 underneath the square root sign, and then on the bottom is just 2. And again, if you were to plug it in on your calculator, you would see that those values, the decimals, do in fact match up. All right, and last, we're going to do tan of 67.5, so that's 135 divided by 2. And here we have a few options, and again, like I said, we're probably not going to use the third one. So I'm going to go ahead and talk through the first and the second one so we can decide which one is maybe a little bit easier to use and then simplify. So we're going to set it up both ways, and then we'll talk about it, and then we'll go ahead and solve it. So one option is to do sine of 135 over 1 plus cos of 135. And then the other option is to do 1 minus cos of 135 divided by sine of 135. Okay, so sine of 135 is it's positive root 2 over 2. So on the top of the one on the left, we have positive root 2 over 2. And then on the bottom, we have 1 plus negative root 2 over 2. For this one, we're going to have 1 minus negative root 2 over 2. And on the bottom, we're going to have positive root 2 over 2. So those are the two things we have so far. So just like in the other problems, we want to take the ones where it's 1 plus a fraction. We want to make those fractions where we can combine the two fractions together so that we can have that common denominator and make it just one piece. So the one on the left is root 2 over 2. And then on the bottom, what we have now is 2 minus root 2 over 2. And on the right side, we have 2 plus root 2 over 2. And that is over root 2 over 2. So if you'll notice, these two problems are turning out very similarly so far. So if we do some cancellation, the 2's right here can cancel. And then this is where you get to see which one of these would be easier to solve. Because right now over here we have root 2 over 2 minus root 2. And over here we have 2 plus root 2 over root 2. And if I had to choose which one of these I wanted to fix, I would definitely choose this one because I don't have to multiply by the conjugate on the top and on the bottom. So when we do these problems, we would get the same answer either way if we worked it out. But if I was you, I would do this formula because it's going to work out more easily. You're not going to have to do the conjugate. So keep that in mind. And that's going to basically work out every time. So if I was you, I'd star that one and say that's the formula I want to use every time probably. Okay, so we're going to go ahead and just finish this one. So now I need to rationalize the denominator, so I'm going to multiply by root 2 on the top and on the bottom. So if I distribute that, then I get 2 square root 2 plus root 2 times root 2 is just 2. And then on the bottom, again, that's just 2. And you'll see that every single piece there has a 2 that you can kind of get rid of. And so these all become 1s. So that is 1 times the square root of 2 is just root 2 plus 1. And if I'm dividing by 1, I don't even need to write it. And there's my final answer. And that was a lot easier than the one on the left would have been to do. So we'll go ahead and leave it there.